interesting topic in regards to what we do as builders and as developers as well, understanding what the process is for a builder. We looked at legal requirements the other day, and this is touching on legal requirements, but now we're looking at more specifically the building codes as a builder, what we need to do, how we build, and why we build that way. So there's a few things, and I'm sure you'll pick up on quite a bit of information. However, it's a very large area, and we can only touch on certain things, unfortunately, because of the time constraints. But as I said, I find it a very interesting topic because it's very relevant to what we do as builders, what materials we use, how we build. This is what building codes teaches you. Why must we build this way? Why must we do things a certain way? And there's logic to everything. Okay, so we're looking at building codes and standards to the low-rise building projects. So low-rise is single-level dwellings, apartments, factories, commercial buildings. So everything up to about 2,000 square meters. Okay, so let's have a look at this. All right, so in this presentation, we'll explore how to access and interpret relevant codes and standards. In other words, where do we find these codes? What are the codes that tell us what we should be doing? And two, this is a very important topic. It's classifying buildings. Now, and I'll get a little bit more into that so we can explore that in more detail. Classifying buildings. So we say this is a house, this is a apartment building. Yes, we know that. This is a factory, this is a commercial building, this is a school. But legally, they have classifications, and these are numbers 1 to 10. Okay, we'll explore that. 3, analyze and apply a range of construction solutions to a construction problem for compliance with the BCA. Well, when we have issues about how to build something or what material to use, then we look at how can we find a solution that is going to be acceptable by the BCA. And finally, apply fire protection requirements. Most of our construction, most of our building is there for the way we do things. They need to take 2 major things into consideration, and that is the ability of a building to stand and not collapse, obviously, under load, and 2, to make sure that people are safe in those buildings, safe from the elements and safe, especially when we have a fire. Okay, very important areas, and that's why the safety of people primarily is the main reason that we have a lot of code that we have to comply with. So they're the things we're going to look at today. All right, so we have what we call the Building Code of Australia / National Construction Code. Now, in fact, the National Construction Code sits on top of the BCA. The Building Code of Australia is part of the National Construction Code. And the Building Code of Australia has 3 volumes. It's Volume 1, Volume 2, and Volume 3. Now, in what we do as builders, we generally just refer to Volume 1 and Volume 2. We do not refer to Volume 3. Volume 3 is for plumbers primarily. Okay. It's primarily focusing on plumbing, Volume 3. So we don't need to look at that. Volume 1 and Volume 2 takes into consideration all the buildings that we will come across as builders. So it's basically the technical guidelines to what materials we must use and how we put buildings together. Now, these 2 volumes contain information for all our types of buildings, all the types of the 10 classifications. they need to make sure that they refer to other standards, and we call these Australian standards. They refer to Australian standards in order that so an Australian standard has a lot of detail, a lot of information about a particular material or a particular way of doing something. Let's take waterproofing. It will say, the BCA will say, you will need to waterproof this building in this manner, referring to Australian standard such and such for waterproofing. So then you go to waterproofing, and it's a very detailed document about what you can and can't do, and how you should be doing waterproofing, what materials to use. Okay, so together with the NCC, the Australian standards form the whole technical basis from which we should be building. Okay, so let's take a closer look at the volume 1 of the BCA. It covers all class 2 to 9 buildings. So that's volume 1. Volume 2, therefore, just covers class 1 and class 10, and we'll have a look at what those classes are. So what things are we looking at in this volume? We're looking at access requirements for people with disabilities, okay, in class 10 buildings as well. And but it covers class 2 and class 9. Now, access requirements is something that the BCA looks at. In other words, how to get in and out of a building. It's called access and egress in the BCA. We can't just put any size doors we need, especially think about large buildings. We have to have a way of getting people out very, very quickly. But also we have to have a way of people getting into the building without struggling with hurting themselves, especially if they've got some disability. So that might mean ramps, yeah? It might mean providing certain, generally it's ramps, but the steps have to be a certain height. The treads and risers need to be of a certain size. So, and it goes into more detail about looking at the width of corridors. Okay? Depending on how many people are going to be in that building, we have to make the corridors wider. Can you imagine if you think about a normal house, let's say, basically a house, we have a standard corridor, might be, just over 1 meter wide. But that's only because you have a family living there or 2 families living there. Now, if you take a hospital, you're going to have thousands of people in there. So the corridors have to be much wider, or a school, they have to be much wider. And these aren't random things that the designers just go, okay, I think I'm going to make this corridor 3 meters, this corridor 2 meters. No, there are guidelines which state how wide a corridor must be, dependent on how many people are in that building. So, but anyway, I'll talk a little bit more about that. But so it's volume 1 looks more into more complicated buildings, such as every other building. So we're looking at commercial, industrial, apartment buildings. Okay, every other building except houses, duplexes, triplexes. Okay, garages. Those are covered in volume 2. So as you can see there, it says low-rise projects of a more complex nature than single residential dwellings, with a gross floor area not exceeding 2,000 square meters. So that's generally the limit of what we're looking at, 2,000 square meters, which is quite a large building for low-rise. Now, the sections of the BCA, so these are the things that the BCA is going to look at. Forget about the general provisions, but the structure, okay, very important. The structure of a building. Fire resistance, very important. Access and egress, I just talked to you about. Services and equipment. Health and amenity. In other words, health and amenity. People need to be comfortable. Imagine living in a house that's got no windows, okay? It's going to be depressing. It's going to be very bad for your health long term, or you don't have enough air. So health and amenity, ancillary provisions, these are other provisions, special use buildings, and section J, which is becoming very important these days, is energy efficiency. Making sure that that building is energy efficient, okay, with a NABERS star rating, as we discussed yesterday. Okay. And volume 2 is class 1 and 10 buildings, other than the disabilities for class 10 buildings, which is in the volume 1. So again, looking at, this is building a house generally, or a low rise, as I said, duplex, triplex. So we're looking at site preparations, footings and slabs, masonry, framing, all the things that are important in a house. So this is where you go to understand what you have to do, what your requirements are. Now, what the BCA says is, and this is very important to understand, that it doesn't tell you that you have to build a house or a building out of this material. It doesn't say it must be out of brick or it must be out of concrete, right? What it does say is, I don't care what you build this building out of, doesn't matter to me or to the law, as long as it meets certain performance requirements. Okay, and those performance requirements relate back to those things that we looked at before, which is structural adequacy of the building and fire resistance. Okay, so it's going to say, as long as you meet these performance requirements, you can build this building out of anything you like. And that's a good thing, because it means it's a performance-based code. It means that you're going to have individuality. You're going to have aesthetically pleasing buildings. It gives a license to people, architects, engineers, designers, to create different buildings, okay? Because it allows you to use different materials. It allows you to use whatever you want, as long as you can meet the performance requirements. So that is what you must comply with. That's called the compliance level. Now, the way to achieve these performance requirements are through two ways. The first way is the deemed to satisfy solution. Deemed to satisfy, it means that this material that we're going to use has been tried, tested, and the BCA is happy for this to be used in a building. That's deemed to satisfy. And that's like me going to hardware store or a supplier and saying, I want to buy off the shelf these bricks, these panels, these. I'm buying those because they have been approved and accepted. And as we discussed in yesterday's lecture on legals, it's got the Australian standards approval, okay? Or it's been tested in Australia, it's been approved to be used in Australia. So they're deemed to satisfy. Now, a performance solution, which was previously known as alternative solution up until the last 4 years when it changed names, a performance solution is where we don't have a material that's been tested in Australia. So I'm bringing a material in from China, or I'm bringing a material from America, or wherever I'm bringing a material in, or even if I develop a new material in Australia, I can't use this in a building because it hasn't been approved. So the only way I'll be able to use it is if I can get it tested, if I can get maybe an engineer who's an expert in that area to say that this is going to work. I need to make sure that I have this approval, and this becomes a performance solution. It means that the product or the method, it's not always about material, it could be the method of doing something, okay? The method of or a combination of materials. So if I'm looking at an external wall, this system, okay, is going to work. It's going to be better or equal to the deemed to satisfy solution. So we have a deemed to satisfy solution that says, you know, in order for you to use an external wall, It must stop the wind, the rain, be structurally strong enough, be fireproof to for this period of time. Okay, then you can use that in this class of building. That's a deemed to satisfy. That's been tried and tested. So the performance solution must be equal to that or better than that. Okay. Right. So just in summary, the performance requirements can be achieved by having a performance solution, or more commonly, we have a deemed to satisfy provision, or it could be a combination of both. And 90% of the buildings we build are deemed to satisfy, based on deemed to satisfy. But sometimes we do come across bringing in new materials in, or a new method of doing something, or a combination of something that we need to prove is going to work. So that's a performance solution. And that takes a bit of time and a bit of money to be able to do that. Okay, so in summary again, deemed to satisfy provisions, they provide, satisfy the performance requirements as the BCA wants. In other words, if you were to construct a building in accordance with the deemed to satisfy provisions of the BCA, then it would achieve the performance requirements and comply. Okay, but if we want to use a material that we haven't, it's not part of the deemed to satisfy. So every time you have a new material, it needs to go through the process of making sure that it's equal to or better than the existing way of doing something. Okay, so I go back to my original example of waterproofing. If I develop a new waterproofing system. Okay, it hasn't been recognized in Australia, it hasn't been tested, the standards don't talk about it because it's new. I develop it, but I can't use it even though I know it's better. Let's say it's been made in China and we know that it's a better waterproofing system in many ways. It's a better material, it's a better product, but we can't use it here. Even though it may have been tested in China and they're using it, we have to bring it here. We have to go through the process of getting it tested and approved to show and prove that it's better or equal to or better than what we have at the moment. Okay. All right. So the Australian standards are quite detailed. As we said, there's hundreds and the BCA discusses over 200 Australian standards, and it makes indirect reference to more than 1,000 Australian standards. And we all have heard of Australian standards, and there's an Australian standard for most things. And it's just getting access to that to see what is required in order to comply. And usually the designers will look at these things before they design a building. They have to understand the codes. They have to understand that. But we as builders need to be aware of that as well. We need to know, what can we do? Are we allowed to do this? Or what is the correct way of doing something? Okay. Okay, so let's look a little bit more at the buildings themselves and why they're classified. What is the building going to be used for? This is a very important point. Is it going to be habitable? In other words, are people going to live, sleep in that building or not? How are the buildings related in relation to one another? Are they joined? Are they far apart? Are they one on top of the other? Okay. How many people will normally be in that building? And that doesn't necessarily mean sleeping. It could mean working. Is the building a healthcare building? Is the building an aged care building? How many cars? Will the building be used for storage or retail? And these are questions, and we think, okay, why do we have to understand these things? Because this will determine how much protection the building needs, how much protection we have to give those people. Because the most important thing in any building is to make sure, as I said earlier, to make sure people get out of the building in time. People are safe, okay? So the building doesn't collapse on them, that they can get in and out of the building without difficulty, but more importantly, that if there's a fire, that people can get out of that building in a very short period of time. Okay, so this is really important. Other things that need to be considered, and I'm not going to go into this today because, as I said, the BCA is obviously quite a large volume, or 2 volumes that are quite large in detail, but things that we need to consider. Why do we need to consider how many people are in a building? It's because we need to know how many facilities to provide. You know, how many toilets do we provide? How many male toilets? How many female toilets? Right? We just don't make that number up. When you walk into a building, whatever building it is, okay, and you go to the bathrooms, you know, you might see there's 5 toilets or 10 toilets, urinal, or, you know, how do they decide? Do they just go, oh, I think we should have, 10 toilets here, maybe 12, maybe 15? No. BCA will tell us exactly how many toilets to have, exactly how many hand basins to have, okay? It specifies all these details. That's why we need to know the number of people in a building. And again, the number of people that can be accommodated in a building will depend on the class of building. This is important as well. This is why I say it's quite a complicated area. So when we look at, let's say, think about this. If I have a 100 square meter building, okay, 100 square meter building of some sort. Now, if that building is an office, maybe I would fit 10 people in that office. However, if that building is a bar, I would probably be fitting, you know, up to 200 people in that building. Okay? Now, this is because the code will tell you how many square meters each person, or how many square meters you need per person in a particular building. It's like this COVID thing now, where they're saying only 1 person per 4 square meters, right? Well, the Building Code of Australia has that rule for every type of building. It will tell you that in a bar, you're allowed to have 2 people for every square meter. But in a retail shop, you need you need 3 square meters for every 1 person in a retail shop. So these are rules that are in the building code. We just don't do what we like. We have to follow certain requirements. And this is why if you look at let's say a shop in a street, and it's going to change its use. It's going to change from a hairdresser to a delicatessen, or you know, whatever, another type of building, fruit shop or whatever. We have to get a development approval, because the council is going to look at the change of use and how that's going to affect the number of people that go into that, and therefore the nature of the building in terms of being safe for people to get out. So I hope that gives you an idea of things, okay? And these are things that a lot of builders don't understand, but it's important to know why things are done a certain way. We just follow generally, well, the architect's drawn that, so we're going to provide so many bathrooms, so many hand basins. No, you have to understand why. And the code tells you why. And it also tells you rules in there that that you must or must not comply with. Okay, so, and you can imagine a healthcare building, like a hospital or an aged care place. We have to think of ways that these people in there are not well, or they're old and they can't move quickly. So we have to, you know, make sure that we can get these people out. You know, buildings are designed so we can get people out from the danger, from the fire, within a matter of 2 minutes. Okay. Okay, so this is the classification. Oops. This is the classification. Oops, again, sorry. and it's a bit small, I know, but this is straight from the BCA, and you can find this on, in many areas, because it tells you the building class and what's in that. So a class 1 is separated into 1A and 1B, and you have a single dwelling, a duplex, a townhouse, villas. Class 1B is a boarding house, but that's when it doesn't exceed 300 square meters or has less than 12 people in it. Once you have more than 12 people or more than 300 square meters, then you need to go to, it becomes a class 3 building, shared accommodation of unrelated persons. Class 1 cannot be below or above another building unless it's a garage. So a class 2 is what we look at residential apartments. Doesn't include villas or townhouses. So you can see that there's each type of building, and they're both, first 3 are more residential, and class 4 is when you have one dwelling on top of another type of building. So one house attached, not necessarily on top, but it's attached to the back of a shop, for instance. So you might have an optometrist and you might have his house at the back of that, or you might have a shop and you have a unit above that. That would be a class 4, the residential component. Class 5 is office or professional spaces. Class 6, retail, where they're selling goods to the public, or restaurants. Class 7A is a car park, any type of car park, underground, above ground. Class 7B is a building which is for storage, where we store things or display of goods for sale by a wholesaler, as a wholesaler. And then we have class 8, which is a laboratory or a factory. And class 9 is separated into A, B, and C: healthcare building, assembly building, aged care building. Schools are in that as well. Okay. Class 10 is a garage, a fence, swimming pool. Okay, and basically that's class, and we don't really worry about bushfire shelters. So that's the way we separate the classes of buildings. So just a visual one on that is very quickly. So we have the multi-story car park is obviously class 7A, and class 7B is a Bunnings warehouse. Class 8 is a factory. Class 9, healthcare building, assembly building, a trade workshop, a school, universities, aged care buildings. Class 10, pretty straightforward. Okay, now, sometimes buildings have multiple classifications. This is a very common thing when we have a car park underground, then we have shops, and then we have apartments above. So they have more than one class. So in this example, you can see the basement is a class 7A, shops are class 6, and the apartments are class 2. And in fact, when you go for a DA in council and you get an approval, they will discuss the building in terms of its classification. They won't say, they'll talk about the building in terms of its classification. So you need to understand these. So remember what we said, the designers have a choice from deemed to satisfy or performance solutions to allow flexibility in the design, as I said. So flexibility allows for new ways of doing things. And sometimes we do things differently because it saves us money, not just because it wants to look different. So if we bring in a different type of material, let's say we bring in a window from overseas, then maybe we bring in that window because it looks fantastic and it performs much better than the ones we're making here. And it's also cheaper, okay? So we may have a purpose to bring it in for cost saving, all right? Now, this is how it is assessed. This is this is the way that a performance solution may be assessed. Remember, the performance solution is we're bringing something else in, we're creating something new, and we need to compare it to the deemed to satisfy. So comparison with the BCA deemed to satisfy provisions. Does it meet or is it equal to or better than the deemed to satisfy provisions? Okay, tick. Doesn't have to tick all of these boxes. One or two or at least one of these boxes must be ticked. Evidence of suitability. Now, evidence of suitability is something that you get from, and the BCA goes into great detail about these things, but it could be an Australian like standards that says, yes, this has achieved this suitability. This is better than or equal to that. So there's a certification process, and that usually requires testing. Okay, and the testing is done by a registered testing authority. So it has to be a registered testing authority, like the CSIRO, like there's, I've been to a registered testing authority in Victoria where they actually conducted fire tests on particular walls. So there are a few of them in Australia that do testing, and it's a very expensive process. Expert judgment. So if an engineer says, look, I'm going to design this, it's different to what the Australian standard says, but I'm going to design it and I've done the calculations and I can show you that it does work. And that's also part of the verification method where you can prove by calculations or testing or other methods. So there's a lot more detail in that, but the BCA does give you more detail in terms of what is in each and every one of those. But understand, I just want you to understand that there are a few different ways of getting a performance solution approved. Right, so whenever we do something, or whenever we're designing something, we have to give certification, evidence that it, so when a, as you can see here, the engineer will say the footing foundation has been designed in accordance with AS 2870, Australian Standard 2870, which refers to how to design footings. And the concrete work complies to AS 3600. The concrete is basically meeting the requirements of the Australian standards for whatever it is, for you know, this slab or this footing or whatever we're pouring the concrete. And the smoke detector has been installed in accordance. So you get the idea? It's showing we give certification. And this is what the PCA, okay, who's the primary certifying authority, whether that's council or what we term a private certifier, an individual, this is what they want, evidence that it's being done this way. The waterproofing has been installed in accordance with AS 3740. So we need certification that it's been done correctly. Right. Fire protection. As I said earlier, it's a very important part of building, providing the fire protection, because fire protection will depend on a number of things, right? The type of building, the nature of the building, class of the building, how many people are going to be in that building, how far away that building is from other buildings. So we have different fire controls. We have active and passive, and I'll briefly explain those soon. Fire resistance levels and checking of existing buildings to make sure they comply. Now, existing buildings are supposed to be checked annually. Every year they get checked. The fire resistance level that we build initially needs to comply with the BCA requirements. And we have active and passive to do that. I'll talk about those now or after this. Different types of fires. I'm not going to go through all of those, but understand that we have different types of fires. Electrical, fires from metals, fires from cooking. So they're classified differently because we need a different thing to put out a different fire sometimes. Okay, if we have a paper fire, then we can use a water-based water or a you know, an extinguisher that's water-based. If we have an electrical fire, obviously we cannot use a water-based extinguisher because that'll make it worse. Okay, so we have to understand the nature of the fire, or potentially what is in that building, that what type of fire would it create. So if we have an electrical room, let's say, we know we can't have a water-based fire extinguisher in there. Or if we have a restaurant next to the kitchen area, we have to have an extinguisher that is going to put out oils, right, and fats. So the nature of the building is going to determine what sort of extinguisher we use. And an extinguisher, a fire extinguisher, is an active means of fire protection. So the difference between active and passive is active means you do something. Something needs to be done in order to try and put out the fire. A passive means nothing needs to be done, that the structure of the building itself is going to put out, is going to assist. So what I mean by that is, if we have a concrete wall or a block wall, that wall might be rated for 90 minutes, right? So it's rated to stop a fire going through for 90 minutes. So that in itself is passive fire protection. So for 90 minutes, that wall is going to stop the fire. So we're not doing anything. It's just the nature of the way the wall was built. So that's a simple example of passive. Okay, so here's more detailed explanation of active. So it's an integral part of fire protection, which we have active and passive, and it requires a certain amount of motion or response to work. Okay, like a fire sprinkler requires a response. It needs something to happen. So the sprinkler, the water comes out. Okay. Active fire control includes extinguishers, fire hydrants and hose reels, sprinkler systems, smoke detection alarm systems. Okay. So in a house, a residential house, we have smoke alarms, don't we? That's an active fire control. Passive. Passive is things like walls, roofs, fire doors, okay? Because the fire door is sitting there and it's going to work when we need it to work if the door's shut, okay? So fire curtains, fire-rated ceilings, fire collars. Fire collars are the ones in between the slabs. If there's any penetrations in the slab, we have a fire collar. So it stops any smoke or fire coming through one floor to another. So you get the idea, active, passive. So fire load is a very important part as to how we're going to, what we're going to do in terms of protecting that building. Very simple example would be if we look at let's say a building where we're storing concrete. Okay? Concrete doesn't burn. But if we look at a building that's storing tires, rubber tires, that burns. So we need to have two different types of buildings, similar buildings, but two different uses. And that's the importance. So one use is pretty good because even if there's a fire, it's not going to become worse. Concrete's not going to burn very easily, but the rubber will create a very big problem. Okay, and I think not too long ago, last year, I think we had a big fire, and with a rubber factory, or a tire factory or something, and those fires can go on for days. Okay, and the toxic chemicals it releases in the atmosphere is very bad. So we need to control these things. So fire load, how much fire load is in a building? Okay. How much storage, how much, what do we have in that building that can burn? Timber. So chemicals, oils. Okay, so we have this thing called FRL, which is the fire resistance level. Now, you will see it when you pick up drawings, architectural drawings, you will see FRL for the slab, for the walls, for the roof, okay? FRL, what does that mean? That means the level of fire resistance, and it's looking at three things. The first thing is the structural adequacy. It means how long that wall or that element must hold the load that it's supposed to be holding. So if I have a load-bearing wall within a building and there's a fire, it says that that wall must hold what it's holding above for at least, and this depends on the type of building, the class of building. It might say 60 minutes, 90 minutes, 180 minutes, okay, 240 minutes. So it will tell you how long you need that wall to hold what it's holding. It might be holding part of the roof, or it could be holding another slab. So every building is going to be different based on the class of building. That's why it's important. And in the BCA, you can find all this information out. If you have an external wall, if it's an internal load-bearing wall, okay, it will say this is what the first thing we're looking at, the structural adequacy. And that's determined by the Australian standard, as you can see there. Now, the next one is the integrity of the element. The integrity means how long it can resist the passage of flames, gases, okay, smoke, in other words, going through the wall. So it may not be, so we have a number that we have, and I'll explain how it works. FRL is three numbers you will see, and you might have a number such as 60, 60, 60, or 60, 90, 90, or whatever. It could be 30, 30, 120, whatever it is. The first number refers to the structural adequacy, and that all the numbers are in minutes. So if you had the first one saying 60, it means that the structural adequacy of that wall has to be there for 60 minutes. Okay? If the next one is integrity, and it's 30, it means the integrity, that wall shouldn't allow gases to go through, or you shouldn't get cracks in the wall that allow gas for 30 minutes. And if the last one is insulation, insulation means so that the temperature, so one side of the wall might have the fire, but the other side of the wall that doesn't have the fire, you shouldn't be able to feel the temperature change for a certain period of time. Okay, so it might be, so it might be 30 minutes, 60 minutes, 90 minutes, whatever. So those three numbers are what is the FRL, and you will often see this in drawings, okay? And the BCA constantly refers to this. So it's a really important part of construction is the FRL, and that's its meaning. So we select materials that have got certain FRL, okay? So a fire door, for instance, will have an FRL. The only difference is with a fire door, the first number isn't there because the fire door isn't holding any load. So the structural adequacy is 0 dash, but it has to have integrity and it has to have insulation. So it doesn't break down. And the integrity is going to be the same as what the wall is. Whatever the wall is, the integrity is going to be the same. All right, so existing buildings. So we check existing buildings annually, as I said. They do, and there's a form that needs to be filled out for checking the essential fire safety measures. Now, these are things that they will check smoke alarms, they will check exit lights in different, especially, we don't have them in dwellings, class 1 buildings, but we have them in other classes of buildings. The green running man you see, right? They have to be able to operate when there's a blackout, okay? When there's no lights, the power goes out. People need to see where they're going. So these things need to be tested. The extinguishers need to be, the fire extinguishers need to be tested for the pressure to make sure that they're working. Fire blankets, okay? You need to make sure you have, back to the extinguishers, the right extinguisher for the right business. Fire blankets, make sure that, you know, a fire blanket to put out any flame over, you know, a cooktop or whatever. So essential fire safety measures, okay? Whatever fire safety measure is in that building, it needs to be checked annually. Obviously, it's not going to be affecting a wall or something. But if you have a fire door, you need to make sure the fire door needs to have a tag on it to show that it's, and the frame needs to have a tag to show the FRL of that door, and to show that it complies with that use of building. So fire safety schedules, where are all the fire, you know, what active and passive fire systems you have in that building. Okay, so this is something that needs to be done annually. And so when you want to, we need these, as I said, as part of the OC initially, as part of the DA, as part of the OC, it needs to be done, okay? And we often get a BCA consultant in the beginning. Once we've got our DA approved, we get a BCA consultant to do a report to show that this is what we're compliant with the requirements of the BCA. And in other times, we also need a fire engineer to come up with solutions and options, especially if we're doing performance solutions. Okay. There is a question there. Questions? Okay, look, I'm nearly finished the slides. I'll get to the questions shortly. Okay. So, so when we have we're going to get a DA, we need to have all this in order. We need to have our consultants who have done the work that's required. Same thing with an OC. They're going to check, the PCA is going to check that it's all compliant. Then we need to make it an annual process where we have somebody inspecting these things annually. Same thing with a CDC. Anytime we have a change of use of a building as well, because we're going, as I said, from one type of building to another, or one use of the building to another use. The building might be the same, but we're changing use. And if that other use is going to have more, it could be more problematic for when there's a fire, there's more people, the nature, there's cooking in there, whatever it is, it needs to be assessed. And obviously, when you, as I said, the construction certificate process is also, you know, you do that, the BCA report will show you what you need to do, what you need to achieve. Make sure that it's all ticked off according to the BCA. Okay, so that's that. All right, so that's basically what I wanted to say in terms of the information for today. Look, it's a very large topic, building codes, the BCA. It covers many things, and some things that I didn't touch on, as I said, the number of people in a building and how that affects the services that we need to provide. You know, but these are things that the architects and designers will look at when they're designing a building.